Welcome to the deep dive. Today, we're really cutting through some of the noise around user research. We're focusing on efficiency. We're diving deep into heuristic evaluation, that foundational, expert-driven method for finding and fixing usability flaws fast.
Yeah, it's a critical methodology. It often
Yeah.
separates like effective, rapid product work from, well, months of potentially wasted development time.
Right.
I mean, if you, the listener, have ever spent weeks, maybe months, designing some really sleek feature,
Oh, yeah.
only to watch real users just completely stumble over the basic navigation or maybe miss the point of a key button entirely. That pain.
That moment is almost universal in design, isn't it?
Yeah.
That sinking feeling when your beautiful design intention just smacks right into user reality.
Exactly.
And users just aren't doing what you mapped out. They get stuck, they get frustrated.
They leave, they abandon the task.
Yeah.
And that failure, that gap between design and actual human behavior, that's what costs companies so much, not just revenue, but time, developer effort, damaged trust.
It adds up.
It really does. And heuristic evaluation, or HE, it's this systematic, expert-led inspection designed to catch those crucial failure points early.
Okay, so it's about minimizing that gap before you pour tons of resources into coding it up.
Precisely, before you commit.
So let's just nail down exactly what we mean by heuristic evaluation. It's an inspection method, right? Experts reviewing an interface against established principles.
Exactly that. It's structured expert judgment. Think of it like building inspectors, but for usability. They use a checklist of known potential problems.
Okay.
And it's quick. It's cost-effective. And it's often high impact because you're finding these high-probability failures before user testing even starts.
So it forces a step back. Are we following the basic rules of human-computer interaction?
Are we, as Don Norman famously put it, designing for the way people behave, not for how we would wish them to behave? That's the core question HE helps answer.
It feels powerful, but you mentioned its origins are maybe less high-tech than you'd think?
Oh, definitely. It has solid academic roots, actually. Jacob, Nielsen, and Rolf Mollick developed it back in 1989.
Okay.
And the context, it was basically pedagogical. They were teaching UI design at the Technical University of Denmark.
No way.
Yeah, they needed a standardized way for experts, them, the instructors, to grade student design projects. So it literally started as a kind of sophisticated grading rubric.
That's fantastic context. A simple need for a repeatable measure leads to an industry standard.
It really did. Nielsen saw how useful these principles were beyond the classroom. So he spent the next few years refining them, validating them empirically. And that led to the 1994 publication of the refined set, the 10 usability heuristics that are, still the global gold standard today for checking interaction design quality.
So those 10 principles, they're the framework. They provide the rules. So expert judgment isn't just random opinion. It's applying proven standards.
Absolutely.
Okay, let's jump into section 1 then. Let's unpack each of these 10 cornerstones.
Let's do it. These 10 points are the absolute heart of the practice. And look, while we focus on Nielsen's 10, mostly because they're simple, broadly applicable,
Right.
it's worth remembering other frameworks exist. Like Ben Schneiderman's 8 Golden Rules, they focus a lot on consistency, efficiency. Or Gerhard Powell's 10 Cognitive Engineering Principles, which dig maybe a bit deeper into mental models.
But Nielsen's 10 kind of won out in popular use.
They did, largely because they work so well as this systematic, comprehensive checklist. They give evaluators the structure needed to spot errors that the design team itself.
Yeah.
Well, they often develop design blindness, right? They've just looked at it too long.
Yeah, you can't see the forest for the trees anymore.
Exactly. So these are the standard. Let's walk through them one by one, and let's try to use really concrete examples, things people see every day.
Okay, number 1, visibility of system status. This one feels super immediate. The system has to keep users in the loop about what's going on. Timely, clear feedback.
It's that constant communication. Users hate ambiguity. If they click something and the system just goes silent.
Yeah, instant anxiety. Did it work? Is it frozen? Did I click wrong?
All of that. Timely feedback just cuts down that cognitive load, that anxiety. Think about like a website loading bar, that little spinning wheel, or the thin line creeping across the top on Amazon or Netflix.
Where?
Even if it takes 10, 15 seconds, seeing something move confirms, okay, it's working. If that feedback is missing, or even just too slow, people start clicking again.
Right. Hammer the button.
And then you get duplicate requests, new errors. So the status needs to be visible, continuous, clear.
Okay, so the system's talking to us. Next step, make sure it speaks our language. Number 2, match between the system and the real world.
This is all about making things feel intuitive through familiarity. Use language, concepts, metaphors the user already knows.
Avoid the jargon.
Definitely avoid the technical jargon, internal product code names, or interface stuff that just defies real-world logic. It should feel intuitive because it mirrors how the user already thinks about the world.
Like skeuomorphism, but used smartly. A shopping cart icon for e-commerce, because we know what a physical cart is. A folder icon, because we used physical folders.
Exactly that. Or think about the heart icon for liking something on Instagram or Twitter. It's not just some random shape. It taps directly into the real-world concept of affection, approval. It minimizes the mental work needed to figure it out. If you use some weird abstract symbol instead,
You'd have to teach everyone what it means, adds friction.
instantly violates the heuristic, yeah.
Okay, speaking of minimizing friction and mental strain, number 3, user control and freedom. Users will make mistakes, they'll click the wrong thing, end up somewhere unexpected. They need an easy way back.
They need that clearly marked emergency exit, as Nielsen puts it. So interfaces have to support universal things like undo and redo.
Essential.
And offer really clear, labeled ways to cancel or back out of long processes without being forced to commit. The emotional relief from this one is huge. Realizing you messed up, but seeing that instant undo button, it calms the panic right down.
And the killer example everyone uses is Gmail's undo send.
Right.
That little window after hitting send where you can pull it back.
Brilliant example. Yeah, it transforms the feeling of control. If a system feels too rigid, too unforgiving, people actually become afraid to interact with it.
Which leads nicely into number 4, consistency and standards. If you give users control, that control needs to feel predictable. Users shouldn't have to guess if different words or actions mean the same thing.
Yeah, this is huge. And we usually break it down into 2 types, right? Internal and external consistency.
Okay, explain those.
So internal consistency is vital within your own product. If save is a green button on page 1, don't make it a purple link on page 2.
Right. Keep terminology, visuals, placement the same.
Exactly. But external consistency. Arguably, that's often even more important because it leverages what users already know from other sites and apps.
This is Nielsen's law of the internet user, isn't it?
Yeah.
People spend most of their time elsewhere.
That's the one. You have to leverage that existing knowledge. If, like, 99% of websites put the login button in the top right corner.
Don't put yours in the bottom left footer just to be different.
Exactly. You're forcing users to learn a new convention just for your site. That increases cognitive load, wastes their time. Stick to standards unless you have a very good reason not to.
Okay, so consistency helps prevent confusion. That leads us to number 5, error prevention. Designing things so problems just don't happen in the first place. Defensive design.
Prevention is always better than cure, right? Instead of just relying on having great error messages, which is a later heuristic, by the way, we should try to eliminate the conditions where errors can even occur.
How do we do that?
Well, anticipate user slip-ups. For instance, if a user must select an item from a list before clicking Next,
Then the next button should be disabled, grayed out, until they select something.
exactly, or using constraints on data entry, like automatically formatting a phone number field as they type.
Or that confirmation dialogue before you do something destructive, like deleting files in Dropbox. Are you sure?
That's a classic example, a crucial preventative speed bump. Think twice before you click this.
Okay, so we're designing defensively. We also need to make it easy on the user's brain. Number 6, recognition rather than recall.
This taps right into basic memory psychology. Recognizing something is way easier for our brains than recalling it from scratch.
Right, like multiple choice questions versus essay questions.
Perfect analogy. When you force a user to recall information, type a specific command. Remember a product code from 3 screens back. You're just inviting errors.
So interfaces should make things visible. Objects, actions, options, keep them out in the open.
Present the information instead of demanding the user dig it out of their long-term memory. That's why, menus are usually better than command lines for most people.
And the classic example, Google search autocomplete.
Absolutely. It turns a recall task, what was that exact phrasing I wanted, into a simple recognition task. There it is in the list. You just see it and click. Minimizes memory load.
Okay, now minimizing load is one thing, but users aren't all the same. How do we handle beginners versus power users? That's number 7, flexibility and efficiency of use.
Right. The system needs to work for both novices and experts. The novice needs clear guidance, maybe tooltips, step-by-step instructions. But the expert needs shortcuts to blast through tasks they do all the time.
We call those shortcuts accelerators.
Accelerator, yeah. Could be keyboard shortcuts, customization options, maybe ways to batch process things. Think about pro tools like Photoshop or, say, a developer's coding environment. They have a visual interface for beginners, sure. But the real efficiency for a pro comes from muscle memory, using dozens of keyboard shortcuts, like Trinus plus Z for undo, Trinol plus S for save, without even thinking.
A system that only caters to beginners frustrates experts, and one only for experts is impossible for beginners.
Exactly. You need both paths. Even on mobile, you see accelerators like gestures. Instagram's double tap to like is faster than finding and hitting the little heart icon.
But the heart icon is still there for those who don't know the gesture. It's optional efficiency.
Precisely. Which brings us neatly to number 8, aesthetic and minimalist design. Now, this one is often misunderstood.
People think it just means make it look pretty.
Yeah, but it's not about prettiness per se. It's about clarity. Interfaces should be clean, free of visual clutter. Every extra piece of information on the screen competes for the user's attention.
The signal-to-noise ratio idea? If 90% of the screen is just decoration or irrelevant info,
It becomes noise. It actively hinders the user from finding the 10% that's actually essential for their task. The mantra here is really, communicate, don't just decorate.
think about Spotify's interface, maybe. Very clean, focused on playback controls, album art, everything else is secondary.
Good example. It ruthlessly prioritizes. But this raises attention, doesn't it? If we go too minimalist, we might hide important controls or helpful info, potentially violating other heuristics. Like, say, help and documentation.
That's a real balancing act. Extreme minimalism can sometimes lead to functional mystery, even if it looks beautiful.
The key is prioritizing based on the user's current task.
Yeah.
If information is relevant now, keep it visible. If it's ornamental or rarely needed, maybe hide it behind a click. Clarity, not just emptiness.
Okay. Now, despite our best efforts at prevention, heuristic 5, errors are still going to happen. So we need number 9. Help users recognize, diagnose, and recover from errors.
The error message itself becomes the recovery tool. When something goes wrong, the system needs to do 3 things clearly.
Okay, what are they?
1, use plain language. No cryptic error codes like error 500 or internal jargon.
Right.
2, precisely indicate what the problem is. Don't just say invalid input, which input was invalid.
And 3.
And 3, most importantly, constructively suggest a solution. Tell the user how to fix it.
So that vague error failed to save message is terrible. It tells you nothing.
Exactly. A good error message, say, for a password that doesn't meet requirements would be something like, password must be at least 8 characters long and include 1 number.
Ah, okay. It diagnoses the problem and tells you how to fix it. Diagnostic and prescriptive.
That's the goal. It empowers the user to recover immediately.
And finally, rounding out the 10. Number 10, help and documentation.
Right. Ideally, a system is so intuitive it needs no help docs. But for anything complex, especially enterprise software, help is usually necessary.
So if we need it, what makes it good help?
4 things, generally. It needs to be easy to search. It needs to be focused on the user's task, not just describing features. It needs to list concrete steps to follow. And it shouldn't be this overwhelming, massive manual.
Bite-sized and contextual seems best. Like those little tooltips you see in complex apps like Salesforce. Hover over an icon, it tells you exactly what it does right there.
Exactly. Embedded help. Contextual help.
Yeah.
That's often the most effective because it doesn't force the user to leave their current task flow to go hunt for an answer in a separate help file. Respects their context and time.
Okay, those are the 10 principles. That's the lens we look through. Once evaluators really get these, how do we actually, do the evaluation?
Right. That takes us perfectly into section 2, methodology and application. We've got the rules. Now the process. How do we conduct this deep dive?
First thing to remember.
Here's to stress again. E is qualitative. It's an inspection method. It gives you rich, context-based insights from experts about why things might be problems and how severe they might be.
But it's not giving you stats on how many users clicked a button.
Nope. Not statistically significant data. It's about expert judgment against principles.
Okay. And the team. You mentioned we don't need a huge group, which helps with cost.
That's a key finding from Nielsen's original research. There's a strong law of diminishing returns with evaluators.
Yeah.
The data really points to a sweet spot of 3 to 5 evaluators.
Fewer than 3. You miss too much.
Yeah, you get blind spots, risk missing major usability catastrophes. But if you go past 5,
You're basically paying extra people to find the same problems the first few already found.
Exactly. The overlap becomes huge. The rate of finding new problems drops way off. It's just not efficient resource-wise.
And the mix of people matters too, right?
Oh, definitely.
Yeah.
The recommendation is to mix expertise. You absolutely want 1 or 2 seasoned UX experts who can spot those deep, maybe subtle structural or cognitive issues. But you also really benefit from including maybe 1 or 2 team members who are unfamiliar with a specific product being tested.
Fresh eyes.
Fresh eyes. They are crucial for catching things that the core team just takes for granted or has developed workarounds for without even realizing it's a problem.
Okay, so we have our 3 to 5 person team, mixed expertise. We've got Nielsen's 10 principles. Let's walk through the actual 5-step process.
Right. Step 1 is absolutely foundational. Define scope and goals. You have to be crystal clear on what exactly is being evaluated.
The whole application, or just one part?
Exactly. Is it the entire mobile app? Is it just the user onboarding flow, the checkout process, a specific new feature, maybe accessibility across the board? Without a defined scope, the evaluation gets messy, loses focus.
Makes sense. If the goal is, say, reducing cart abandonment, you'd focus the HE heavily on the checkout flow specifically.
Precisely. Scope dictates relevance. Step 2. This one can be tough, especially for internal folks, but it's critical. Know the end user.
Put yourself in their shoes.
Completely. Evaluators have to shed their own expert knowledge, their own assumptions, and adopt the target user's mindset. Their goals, their needs, their tech savviness, their context.
So if you're evaluating a financial tool for retirees, you can't review it like a 25-year-old developer would.
Absolutely not. You need to use personas, user research data, whatever you have, to genuinely simulate that user's experience. This prevents evaluating based on your own preferences.
Okay, adopt the user persona. Then step 3, decide on specific heuristics.
Right. While Nielsen's 10 are the default standard, the entire evaluation team must agree on and use the exact same set. Consistency is key for comparing findings.
Could you ever use a different set?
Yeah, sometimes. If you have a very specific focus, like evaluating for accessibility, you might use Nielsen's 10 plus a set of specialized accessibility heuristics, like WCAG principles framed as heuristics. The point is, everyone uses the identical measuring stick.
Got it. Uniformity. Then comes the part where we avoid groupthink. Independent review. Step 4.
This is crucial. Each evaluator works alone. No discussion, no comparing notes yet. They interact with the interface, trying to complete realistic tasks defined by the scope and user goals.
And they document everything as they go.
Meticulously. When they hit a snag or see something confusing, they document it. Usually a screenshot, a clear description of the issue, which specific heuristics it violates, e.g. violates HV4 consistency, and the context what they were trying to do.
Lie alone.
Prevents bias. If you have one dominant or senior expert in the room, they might unintentionally sway others' opinions. Working alone ensures you get unfiltered, independent findings from everyone.
Okay, makes sense. Everyone does their own work separately. Then step 5 is bringing it all together. Identify, prioritize, and compile findings.
Right. Now the team collaborates. They bring their individual lists, pool all the findings. First step here is usually debriefing and grouping, finding duplicates or very similar issues and consolidating them.
Get through the noise.
Exactly. Then comes the most critical part for making this actionable, assigning severity ratings. This turns a long list of observations into a prioritized action plan.
And you mentioned a common scale, 0 to 4. How does that work? What's the difference between, say, a 3 and a 4? That seems important.
It's crucial for deciding what gets fixed first.
Yeah.
So, roughly. 0 equals not really a usability problem, maybe just a comment or cosmetic suggestion. Ignore unless easy. 1, minor cosmetic issue, like alignment off. Low priority. 2, minor usability problem, low impact, user can easily overcome it. Fix if time permits.
Okay, so 1 and 2 are annoyances. 3 and 4 are the serious ones.
Exactly. Severity 3 equals major usability problem. The user will likely struggle, maybe need a workaround, might get frustrated, but can eventually complete the task.
Oh, yeah.
This needs high priority fixing, definitely before the next major release. Severity 4, usability catastrophe. The user is completely blocked from completing the task. Maybe data loss occurs or the core function of the feature fails. These are showstoppers. Must be fixed before launch or release. Often means stopping development work until it's resolved.
Wow, okay. So the severity rating directly dictates the urgency. Fix the 4s first, then the 3s.
Absolutely. Teams often use a priority matrix plotting severity against maybe frequency or user impact to decide the final order. And the output, the final report, needs clear, actionable recommendations.
Not just search is confusing.
No. Something specific like move the primary search bar from the left sidebar to the global header, top right, to comply with H4, external consistency, and user expectations. Actionable.
That systematic process really explains why HE fits so well with modern development like Agile or Lean UX.
Oh, it's almost perfect for it. Agile thrives on short feedback loops, right? Build, measure, learn. You can't wait weeks for a big user testing study to finish before you can iterate.
Right. Sprints are often just 2 weeks long.
Exactly. He can deliver high-quality, actionable feedback in, maybe a couple of days, sometimes even hours. It lets you debug the design rapidly before you invest heavily in debugging the code. Saves enormous amounts of time and money downstream.
And it's interesting how these principles, penned way back, still apply to tech that didn't even exist then, like AR or voice.
The core principles about human cognition hold up surprisingly well. But yeah, the application requires some fresh thinking for these newer interfaces. We still use the heuristics, just interpreted differently.
So for, say, AR, VR, what changes?
Well, think about consistency, H4. In VR, it's less about button placement on a 2D screen and more about spatial consistency. Are controls always found in the same relative physical space? Does the environment behave predictably? User control and freedom, H3, becomes hypercritical. Having a clear, instant, easy-to-access emergency exit from a potentially disorienting VR experience is paramount. Prevents panic, maybe even motion sickness, which itself could be seen as a violation of system status, really. Recognition over recall, H6, might mean ensuring vital info appears directly in the user's field of view when needed, not hidden somewhere they have to remember to look.
And for voice UIs, VUI, like Alexa or Google Assistant, there are no visuals at all. How do the heuristics apply there?
It's all auditory, yeah. Match between system and real world, H2, means the VUI needs to speak conversationally, using natural language, not robotic phrases or jargon.
Okay.
Error prevention, H5, involves designing the language model to understand the many different ways that user might phrase the same request. Anticipating variation. And when errors do happen, help and recovery, H9, H10, means the VUI should offer clear, simple fallback options. Like instead of just saying, sorry, I don't understand, it might ask, did you mean X or Y, guiding the user towards success through voice. Clarity is still key, just delivered via sound.
That adaptability really shows the staying power. Okay, we've covered the what and the how. Let's move into section 3. The value proposition. The why teams use HE, but also, crucially, its limitations.
Right. The why is pretty compelling. The big headline is speed and cost. It's just much faster and cheaper than running large-scale usability tests with real users. Fewer people, less time, fewer resources needed. Some studies suggest it can save up to like 40% on testing costs overall.
And because it's fast, you get early detection. Finding a major flaw during wireframing costs almost nothing to fix compared to finding it after it's been fully coded and integrated.
It's a massive risk reduction strategy, and it is effective at finding big problems. Research suggests HE typically identifies somewhere between 75% to 85% of the major usability issues in an interface.
So it catches the big stuff.
It's very good at catching the big critical blockers. And its relevance holds up because fundamentally human psychology, how our memory works, how we perceive things, hasn't really changed. Those Nielsen principles are grounded in that consistency.
Okay, compelling advantages, but we need the full picture. There are major caveats, right? Misconceptions and limitations.
This is probably the single most important point for you, the listener, to take away. Heuristic evaluation is not a replacement for testing with real users, period.
It's a complement, not a substitute.
Exactly. Think of it like an expert mechanic checking over a car before you take it for a real test drive. The mechanic finds potential issues based on experience, but the test drive tells you how it actually feels to drive in real conditions. You need both.
And the research on HE's accuracy? It's kind of startling, actually. This is where we hit the big warnings.
Yeah, the data here is really important to understand. Studies comparing HE findings with actual user testing results show two major limitations. First, false positives. Nearly 43% of the problems flagged by expert evaluators might not actually affect real users in practice.
Wait, 43%? Almost half the issues experts find might just not matter to users. That seems high.
It does seem high. The thinking is it often comes down to expert bias or expert projection. The expert knows the heuristics inside out. They approach the interface almost looking for theoretical violations. This icon isn't quite consistent with that other screen, H4 violation.
Right.
But a real user, focused solely on, say, buying a train ticket quickly, might not even notice that inconsistency, or they might have an intuitive workaround. The expert flags a theoretical flaw that has little practical impact on task completion for a motivated user. So development time could be wasted fixing these non-problems.
Okay, that's a huge risk. What's the second big limitation, finding the real problems?
That's the other side of the coin. Research also suggests that HE evaluators might only catch around 21% of the actual usability problems that do trip up real users during testing.
Only 21%. So experts find a lot of things that don't matter and miss most of the things that do matter. That sounds really problematic.
It highlights the limitations starkly,
Yes,
doesn't it? This points to the issue of context missing. Experts simulate the user context, but they can't replicate the messy reality.
Like trying to use an app while distracted or under time pressure or maybe with specific accessibility needs.
Exactly. Or cultural nuances, highly specific domain knowledge, complex workflows unique to a certain job, things that only emerge when real people use the product in their actual environment. Experts, by definition, aren't those typical users.
And the quality of the HE itself depends heavily on the expert doing it, right? Reviewer dependency.
Absolutely. A novice evaluator might just spot the obvious stuff, inconsistent buttons, H4. A really seasoned expert might see deeper issues related to cognitive load, H6, or information architecture, violating H8 implicitly. The quality and depth of findings can vary dramatically based on who you get.
So, knowing these risks, what are the common mistakes teams make when they try to implement HE?
The sources usually point to about 4 main traps to avoid. First, as we just discussed, relying on a single evaluator. You absolutely need that 3 to 5 person range for better coverage and to average out individual biases.
Okay, don't go solo. Second,
Skipping the user context. Evaluating purely from an expert perspective without deeply considering the target user's goals, skills, and environment. That leads directly to that high false positive rate.
makes sense. Third mistake, something practical.
Very practical. Forgetting to assign severity ratings. Handing developers a long, unprioritized list of 50 usability issues is almost useless. They won't know where to start. Severity ratings that 0-4 scale are essential for making the findings actionable.
Prioritize, prioritize, prioritize. And the last common mistake,
Focusing too narrowly. Not testing the entire end-to-end flow, just looking at individual screens in isolation. Many usability problems only pop up during the transitions between screens, or when data is being processed, or when a task requires moving between different sections of an app. You have to simulate the whole journey.
Okay, avoid those traps. So HE is one tool. How does it fit alongside other inspection methods? Let's quickly compare it to, say, a cognitive walkthrough and a full UX audit.
Good comparison. They often get confused. Heuristic evaluation, as we've said, is broad. It's a general checkup against established usability principles across potentially the whole interface.
Like a physical exam?
Kind of, yeah. Now, a cognitive walkthrough, CW, is much more focused, much narrower. It specifically examines the learnability of a particular task, especially for first-time users.
How does it work?
Evaluators meticulously step through a specific task flow, say, the sign-up process, from the perspective of a complete novice. At every single step, they ask questions like, will the user know what to do here? Is the action's effect obvious? Will they see the control? It's really about predicting problems a beginner might face.
So HE is general health. CW is troubleshooting for beginners learning a specific task.
You got it. Now compare HE to a UX audit. This is about scope. HE is usually one input into a much larger UX audit.
An audit is bigger picture.
Much bigger. A UX audit is a comprehensive strategic assessment of the entire user experience. It takes the HE findings, yes, but layers on quantitative data, like website analytics, conversion rates, user feedback, surveys, interviews, competitive analysis, how do we stack up, maybe market trends, business goals, the whole strategic landscape.
So the HE finds specific usability flaws. The UX audit puts those flaws into a business context and creates a strategic roadmap for improvement.
Exactly. He spots the what's wrong, the audit helps figure out the why it matters, and what to do about it strategically. Different levels entirely.
This has been incredibly thorough. We've really unpacked heuristic evaluation, this fast, qualitative, expert-based method anchored by Nielsen's 10 principles. It's clearly a foundational tool.
It really is, especially for catching those major usability roadblocks quickly and cheaply, which is invaluable in fast-paced environments like Agile. Gets you 75–85% of the big issues.
And it stays relevant because it connects back to fundamental aspects of how people think and interact with technology.
Its speed and low cost make it a go-to first check.
But, and it's a big but, we absolutely have to remember the risks. That potential for wasting time on fixing problems users don't care about the 43% false positive rate.
Mhm.
And maybe even more worrying, the risk of missing most of the real pain points that only surface with actual user testing, only catching maybe 21% of those.
It's a trade-off.
hmm
Speed and expert insight versus the nuance and reality of actual use.
Which leaves us, and you the listener, with a really critical ongoing challenge in design practice, doesn't it?
It really does.
Given that HE is fast and cheap, how do you decide? When do you trust the expert findings from an HE and just fix the reported issues immediately? And when you absolutely need to pause and spend the extra time, the extra budget on real user testing to validate those findings, especially the critical ones?
Finding that right balance between expert speed and authentic user reality. That's where the true art, the mastery of effective product development really lies, isn't it?
A crucial question to wrestle with. Something to think about as you plan your next design cycle.
Definitely food for thought. Thanks for diving deep with us today.
We'll catch you next time for the next deep dive.